Today we're going to use our cross products property to figure out an unknown value. So when we look at these ratios and we are saying that these are going to be proportions, that they are proportional to one another, I can use this property, the product of my means equals the product of my extremes, in order to solve for my variable. So looking at this first example, I have x over 21 equals 1 over 3. This one, you might actually be able to figure out what x's value is. If you're looking at the ratio of 1 to 3, we know that, well, 7 to 21 is the same thing as 1 to 3 because they would both reduce to the same fraction, so they are proportional to one another. However, we can use our cross products property to solve this. So what I like to do is I always like to multiply my variable first. So I'll take x times 3. So product of my means, so that would be 3x, equals the product of my extremes. So 3x equals 21. Now you'll notice that we do have a one-step equation. So we're going to solve this, and we're going to divide by 3 on both sides, and you're going to get x equals 7. So we did know that x's value was 7 just by looking at the equivalent ratios. Sometimes it's not as obvious. If I have x to 6 equals 4 to 8, here I can just simply use my products of my means equaling the products of my extremes. Use that cross products property. So again, I'm going to multiply 8 times x to get 8x. I'm going to multiply 6 times 4 to get 24. So the product of my means, so 8 times x, which is 8x, 6 times 4, which is 24. They're equal in a proportion. So I can use that knowledge to create these equations. So I'm going to divide both sides by 8, and x is going to equal 3. So you may have noticed that if you did take 4 to 8, well, that reduces 1/2. So what value to 6 is also going to reduce 1/2? Well, that's going to be 3. Now, if we look at these next two examples, they're not as evident. Sometimes my answer is going to be an integer. Sometimes my answer is going to be a rational number. We don't really know until we kind of get in there. So if you're looking at this next one, I'm going to use my cross products property because I don't know what factor to multiply 9 by to get to 24. So to do the same thing to 15 is not as apparent. So I'm going to use 9 times x. Again, I'm just going to start with the product of my variable with its cross product. So 9 times x is 9x. And then 24 times 15 is going to be 360. I almost forgot there. So 360. So now I can divide both sides by 9. And I'm going to get x equals 24. 40. Just kidding. Not 24. 40. I was looking at the wrong value. So x's value is 40. So it's not as evident, 15 to 9, the ratio of some value to 24. It's not as evident to figure out that, oh, okay, that's going to be 40 to 24. So this next problem that I'm going to do, again, I'm going to use product of my means equaling the product of my extremes. So I'm going to set them equal to one another. 10 times x, I always use my variable first, so 10x equals, and then 9 times 15, that's going to give me 135. You'll notice in this one, when I do divide by 10 on both sides, I'm going to actually get a decimal. X's value is going to be 13.5. I did not know that. I did not know the ratio of 10 to 5, or 10 to 9, was the same thing as 15 to 13.5. So we can use our cross products property to figure out these missing values. We could also reduce. We could take like a number 1 here up at the top. We could have taken our 1 to 3 and looked at what value to 21 is going to reduce to the same thing. But sometimes I find it's quicker and more efficient to use this property.